Hello everyone, I am Srinivas, PGT Physical Science from TMRS Mobile Boys. In our previous videos, we have seen the valence shell electron pair repulsion theory and also the drawbacks of that theory. The main drawback of valence shell electron pair repulsion theory is it couldn't explain the bond strengths in the covalent molecules. Right, to overcome this, Linus Pauling has put forward a theory known as valence bond theory. This theory is based on the quantum mechanical approach, that is studying something in the molecular level, that is in the subatomic particular level, is known as the quantum approach. So here, according to this theory, the covalent bond, let us look into this theory. According to this theory, a covalent bond is formed by the overlapping of valence atomic orbitals of the two different atoms or of same atoms or of the same elements, where they are having one unpaired electron each with opposite spins. Those atomic orbitals will overlap, and that overlapping will lead to the formation of a covalent bond. See, let us take the example of hydrogen bond, hydrogen molecule. If you take a hydrogen, you know that there is one electron in this hydrogen with plus of spin, and the other hydrogen which is going to take part in this bonding should have an unpaired electron with opposite spin. Now these atomic orbitals, 1s atomic orbitals of the two hydrogen atoms will overlap each other. They will overlap. Here what will happen? Overlapping will happen. Overlaps, and they leads to the formation of a hydrogen molecule where the two unpaired electrons will be paired up. They will pair up and they lead to the formation of H2 molecule. Strength of the bond depends on extent of overlapping. Extent of overlapping. Greater the overlapping, greater will be the strength of the bond. So if it is overlapping to the greater extent, then the strength of that bond will be more. Right, and in addition to the valence atomic orbitals, individual atoms will have their own atomic orbitals, right, and the electrons will be inner atomic orbitals will be there with the unbonded electrons in them, right. If a molecule is with multiple bonds, so this is about a molecule with one bond, and if a molecule is with multiple bonds, first the end-on end overlapping, okay, face-to-face overlapping, end-on end overlapping of valence atomic orbitals occurs, and next the remaining valence atomic orbitals will overlap sideways, that is perpendicular, lateral overlapping. That overlapping will lead to the formation of the next bond, that is pi bond. This end-on end overlapping leads to what? A strong bond, that is sigma bond, be formed by sidewise overlapping. Okay, say this is an atom A and this is an atom B. This sidewise overlapping, that is end-on end overlapping, will lead to sigma bond. What is this bond? Sigma bond. This is sigma bond. Next, the remaining valence orbitals will overlap perpendicularly. This overlapping, these atomic orbitals are perpendicular to the axis, right. These perpendicular orbitals will overlap and they lead to the formation of a pi bond. This is pi bond, which is a weak bond, okay. So in this way, based upon the number of bonds, the pi bonds will be increasing. So one sigma bond will be there, and if it is a double bond, there will be one pi bond, and if it is a triple bond, there will be two pi bonds. The other remaining atomic orbitals, valence orbitals will overlap, and they lead to the formation of one more pi bond. So in this way, multiple bonds will be having two types of bonds, covalent bonds, that is sigma bond and pi bond. Sigma bond, as its bonding is end on end. Sigma bond is formed by what? Sigma bond is formed by end on end overlapping bond. So in this way, valence bond theory, VBT theory explains that the covalent bond formation occurs when the atomic orbitals with 1 unpaired electrons in the valence shell overlaps with the other atom which is having opposite spin in its valence shell. That overlapping will lead to the formation of a bond, that is covalent bond. And the strength will be depending upon what? Extent of overlapping. If they overlap to the stronger extent, to the full extent, then the bond strength will be maximum. And if that overlapping is less, then the bond will be weaker. Right? And multiple bonds. Coming to the multiple bonds will be having two types of bonds, that is sigma and pi. Sigma bond will be formed by end on end overlapping, whereas pi bond will be formed by sidewise overlapping. Right? Now let us try to look into the molecules, how the molecules will be formed. We have seen hydrogen molecule. Now let us see a halogen chlorine, formation of chlorine molecule. Now if you take a chlorine atom, you know that this is having the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. That means this will be having, chlorine will be having one unpaired electron in its orbital, right, in its valence. This atom with one unpaired electron will be interacting with another chlorine atom with this one unpaired electron will be overlapping with another one unpaired electron of another chlorine atom, and this overlapping will lead to a molecule between them. Here this overlapping between the two chlorine atoms will be forming a bond. This PZ has led to PZ sigma bond. This is formed by the overlapping of PZ atomic orbitals of the two chlorine atoms molecule. If you look at the formation of HCl molecule, here HCl molecule is also a covalent molecule, and if you see the formation, 1s atomic orbital of hydrogen. What is this atomic orbital? 1s atomic orbital will be overlapping with 3pz atomic orbital, 3pz orbital of chlorine. What is this? This is 3pz, and 1s atomic orbital of hydrogen will overlap, and they leads to the formation of a bond between hydrogen and chlorine. Right? Hydrogen, and this is what? Chlorine. Right? HCl molecule will be formed by the 1s 3pz overlapping, 1s 3pz, and this is what? Sigma bond. Bonds. Multiple bond containing molecule is, example, O2, N2 are the examples. Let us take the nitrogen molecule. See, nitrogen, if you take nitrogen, it is having 1s2, 2s2, 2p3. Right? See here, this is having 3 unpaired electrons in the p subshell. 3p, 2px, 2py, 2pz. These 3 unpaired electrons are going to overlap with the 3 unpaired electrons of another nitrogen atom. If you take nitrogen, this nitrogen is having, right, and I have represented only the 3p orbital, 2p orbitals. 1, 2, 3. This is one nitrogen and another nitrogen. With unpaired electrons in opposite spin will be overlapping now. See, if you take these 2 atomic orbitals, they lead to the formation of sigma bond. Why? Because this is end-on end overlapping. End-on end overlapping. So they form sigma bond. Now let us assume that this is px and this has py, this has pz, this has py and this has pz. This py will overlap with another py atomic orbital and this will form one pi bond, which is of what? 2py, 2py. Okay. Next, again one more overlapping will occur between 3pz and 3pz. See here, this is one more pi bond with 2pz, 2pz. Overlapping of 2pz of one nitrogen and 2pz of another nitrogen. So this kind of overlapping will lead to the pi bonds. So now nitrogen molecule will be formed with one sigma bond between the 2 nitrogens and pi bond surrounding that sigma bond. This is a pi bond. These 2 are pi bonds and in between there is a sigma bond. In this way, nitrogen molecule will be formed with one sigma and 2 pi bonds. Sigma between 2px, 2px, pi bonds between 2py overlapping and another pi bond with 2pz, 2pz overlapping of another nitrogen. So this is how a multiple bond formation occurs. VBT says is unpaired electrons only will participate in the bonding. So if you take, we know that beryllium chloride is also a covalent molecule. What is this? Beryllium chloride. But if you take the configuration of beryllium is with 1s2, 2s2. If you look at the orbitals, they are with no unpaired electrons. Here there are no unpaired electrons, but beryllium is forming bonds with chlorine and it is forming beryllium chloride. But there are no unpaired electrons, still it is forming. So here there is a doubt how this is forming a beryllium chloride molecule, how the bonding is occurring here. So this couldn't be explained by this, isn't it? We have seen this, that beryllium will be overlapped, beryllium will be forming 2 sigma bonds with 2 chlorines. So this couldn't be explained by this explanation because there are no unpaired electrons. In the earlier case, what we have seen is in every case there is one unpaired electron. Due to the overlapping of unpaired electrons in the valence shell, they are forming their respective bonds. But here there are no unpaired electrons, but still it is forming bond. This was not explained by this VBT theory. So Linus Pauling has proposed the concept of hybridization to explain this bonding. In the next video, let us see what is hybridization.